Lecture 3 is about chromatic intervals and their relationships to key signatures and scales. So it's very important for us to start off with a scale review and to look at the intervals that are used to create scales. So we're going to start with the major scale, which is the most important scale in our tonic system. And so with the major scale, you look at the diagram, you'll notice the red slur marks and then the bracket over the top indicate the whole step, half step pattern. So playing it again. I'm going to emphasize the half steps. So it's an H-symmetrical scale, but it's very important to know that relationship because then when you change keys and you start on a different note, let's say E flat, it's the same pattern but transposed on a different starting note. Now that's absolutely crucial in understanding how this all works. You will recall from the last lecture that we introduced harmonic intervals. And so on. And harmonic refers to notes that are played simultaneously. Diatonic means if it's belonging to a specific key. So in this case, all these diatonic intervals belong to the key of C. So we call them harmonic diatonic intervals. And of course, the interval is a distance between any two notes. Now this is crucial to understand because it's going to get a little more interesting. We have something that really helps us understand tonality and understand the relationship of intervals, and that's known as the gravity of the tonic. So if you will, all paths lead to the tonic triad. And now that's a three-note chord built on the tonic. So it would sound, if I would end up with that chord sound at the end, which is made up of the first scale degree, the third, and the fifth scale degrees played simultaneously. Now what I want you to notice about this particular scale is that every note has a tonal tendency. Now the most powerful note is the tonic because that sets up the key, it makes all the chords that work with it land on that tonic. So watch what happens if I play the scale and I stop on the seventh note. It begs to resolve up because that seventh note is called the leading tone and it leads up to the tonic. So that always wants to go up. If I'm going the other direction, that A, the 6, always wants to go down to 5. And then 4 wants to go down to 3. Its natural tendency in a tonic key is to move from 4 to 3. And then 2 wants to go to 1. Now if I go the other direction, the E, because there's a half step, wants to go up to the F. Those are the only two major tendencies when it's ascending. But for almost everything we're going to do, everything leads to the first, third, and fifth scale tone. So that we end up with this. That's the gravity of the tonic. Now what does that have to do with intervals? Well, we end up with functional names of all these diatonic scale pitches, and those functional names are crucial in understanding how they work. So first of all, you'll see on this diagram, which you've seen before, we have an ordinal number. That's the caroted number on top. So the scale degrees 1, 2, 3, 4, 5, 6, 7, and 8. That's crucial to know because when we start making chords, we're going to use the same numbering system. The functional names are crucial. The function, at times also known as a diatonic function, it denotes the relationship of a chord or a scale degree to a tonal center, or the tonic. So the tonic is called tonic because of the tone of the scale of the key. Supertonic is just the note just above. It's super, above the tonic. The mediant tone is in the middle between the tonic and the next most powerful note, which is the dominant, which is the fifth note. The note underneath the dominant is the subdominant. And then between the dominant and the upper voice of the tonic, we have submediant. And then if it's a flatted seventh, we call it a subtonic. But if it's the natural seven, we call it the leading tone because it's leading up to the tonic. Now, these functions are crucial in understanding how all of this works eventually, especially when we're using chords. So we have a very practical application to composing and analysis. The functional name indicates the relative power of a chord in a key. So I'm going to play this little example for you. So for instance, if I have the 1 chord built off the first scale degree, then the 4 chord, then the 5/7 chord, the 1 is very powerful. It's home base. The 4 and the 5/7 chords are subordinate and lead eventually to the 1 chord, the tonic chord. So the chord is named after the scale degrees. And we'll get into that in much greater detail later. But it also describes how to create melodies that emphasize the tonic. So in this one that demonstrates leaps and steps and scale fragments, listen to it. You can see that it starts and ends on the tonic, and the last 4 notes have a leap to the 2nd scale degree. I just could have ended it this way because 2 wants to go back to 1, and 2 happens to be D in this key. But this one uses both of them. It uses 5, and it uses 2, and then 7. So the 2 can be in any octave. So that describes how the notes themselves, with the functions that I'm showing you before, subordinate to the tonic to make tonal music work. Now, interval quality names are very, very important because it tells us the difference between major, minor, augmented, diminished, and perfect. All the diatonic interval qualities are named either major or perfect. So if you look at this chart, we have a perfect unison, 2 notes, 2 instruments, 2 singers playing the same note, major second, major third. Now listen, it's not a major fourth. It's called a perfect fourth. Then a perfect fifth, major sixth, major seven, perfect octave. And we abbreviate using the capital M or the capital P. So you'll notice on that particular staff, I've got the P for perfect, the M for major, and then we have U for unison and so on. But all the diatonic fourths, fifths, and octaves are considered perfect. All diatonic seconds, thirds, sixths, and sevenths are major. So they're named in that fashion. Now the question, why? Why these names? Perfect intervals, I'll play a perfect fourth for you. When I invert it, in other words, I take the bottom note, put it on top, makes another perfect interval. Fourths make fifths. What's really interesting is that when I invert things, sometimes they change quality, but in this case they don't. They stay perfect, hence the name perfect interval. So look at the chart, the perfect unison. If I take that low C and I put it on top, I get a perfect octave. It's almost no change in sound. That's a perfect interval. The perfect fourth, if I flip it over, still has that same hollow sound. And the perfect fourth becomes a perfect fifth. Perfect fifths become perfect fourths. Major seconds become minor sevenths, which is really interesting. Major turns into minor in every instance. So if I have a major sixth, it turns into a minor third. That's why they're not perfect. So that distinction is very, very important for us, And as we do drills on this and we work on it a lot, this will become really familiar to you. Then we've got some further possibilities with all this crazy stuff. And one of the fun things about this is we're not going to limit ourselves to diatonic intervals. Music would be horribly boring if we did that. So what we're going to do is we're going to use chromatic notes. It comes from the Greek word chroma, which means color. And the chromatic scale is all the musical colors, if you will. A chromatic scale is a non-diatonic scale, and it consists entirely of half-step intervals. Since each tone of the scale is equidistant from the next, it has no tonic. There is no tendency. Chromatic scales just kind of float. They have a direction, but they just don't land anywhere. And so when we notate it, here's the convention you use when you're notating a chromatic scale. You write the ascending version with sharps. So from C, go to C sharp, D, D sharp, E. Now it's every key on the piano. And you can listen to this. Now descending. And for descending, we use flats. Sometimes we'll use naturals in place of sharps or in place of flats, depending on what key we're in and where the chromatic scale occurs in that key. But this is the general convention: sharps on the way up, flats on the way down. So the chromatic scale on the piano keyboard just looks like that. It's every note. And that brings us finally to chromatic intervals. And chromatic intervals are going to be something we're going to use in every piece that we compose and analyze. So they include the previously discussed diatonic, perfect, and major intervals. And they can have enharmonic equivalent names. Now, all that means is that like F sharp and G flat sound the same, but they have two different names depending on their context. So here are the chromatic intervals within the span of an octave. And you'll notice that it's really interesting. We have the perfect unison, then an augmented unison, and a minor second, which sounds the same. So it's a second, but because the top note's flatted, it sounds minor. Because seconds will become minor, perfect intervals will either become augmented or diminished at first. So those are all the chromatic intervals. And we'll not only work on some exercises in the book, but we'll do a lot of exercises identifying these. So what I'm going to teach you today is how to identify them. So they have some very interesting interval names. So you'll notice, for instance, that the perfect unison, followed by a C against a C sharp, that's an augmented unison. That's what the plus sign means. And it's the minor second, as I mentioned before, C to D flat, sounds identical. Since it sounds identical but spelled differently, we call them enharmonic equivalents. So they're not exactly equal, they're equivalent to each other, but they're enharmonic in that they sound the same. So that's true for C to D sharp. So D sharp and E flat are enharmonic equivalents. E and F flat are enharmonic equivalents. E sharp and F are enharmonic equivalents. So you can have them for almost any two notes that are adjacent. But what's really great about this is that this helps us understand the logic of the way these intervals work, and it's very, very consistent. So we're using large case M for major, lowercase m for minor, the plus sign for augmented, which means we're raising an interval a half a step, and then the zero diminished, meaning we're lowering it a half step if that is a perfect interval. So here is something that I found to have a great value. You also find this PDF in Canvas. It's the interval alteration chart. So if you look on the screen, very carefully up in the right-hand side, it says major key diatonic intervals. I'll put my cursor there. And so this is the place you start to read this chart. Now that should look familiar. You've got all of the major and perfect intervals right here. So what this chart does, it shows us on this horizontal axis all of the unisons, all of the seconds, all of the thirds, and so on. But how you read it is you pick what interval you want to start with. So I'm going to start with perfect unison. Now if I raise it a half step, it becomes augmented unison. Well, what if I raise it another half step? Put a double sharp. Then it becomes doubly augmented unison. Those are not common. We're not even going to use them, but this is just a theoretical concept so that you understand how the logic works. Now on perfect intervals, and if you look at perfect fourth, perfect fifth, perfect octaves, and perfect unison, if you lower them a half step, they become diminished intervals. Now let's look at the major ones. So if let's say a major third and I raise it a half step, it becomes augmented. So what's so fascinating is all of the diatonic intervals, if you raise them a half step, become augmented. But if you take a major interval and lower it a half step, it becomes a minor interval. You have to lower it 2 half steps to get it to be diminished. And we don't see those very often. So the ones that are right in the middle, you can see where my cursor is kind of circling around them. Those are the most common intervals. Now what's the value in this? It's that we can really use this chart to help figure out what interval we're looking at, what chromatic interval specifically. So identifying chromatic intervals is pretty straightforward. I'm going to give you a step-by-step method using the diatonic method. Now there's some people do it all by half steps. I think that's totally confusing, but this is like bulletproof and really easy to do. And once you catch it, it's just like so simple. So the first thing you do is determine the size of an interval. So if I see 2 notes, I'm going to count the size by assigning the lowest note as 1. So right here you can see on my chart, between this F and this D, I'm counting the lowest note as 1. Then I count up every space and line. 2, 3, 4, 5, 6. So since that D falls 6 above, it's called a sixth. It's that simple. The important thing is don't start counting on any other line or space. Start counting the bottom note as 1 and then just go up and alternate line, space, space, line, whichever happens to be next. That's the first step. So I don't care what interval you're looking at. If you have 2 different notes, start counting from the bottom and work your way up to the top. That gives you its size. It's really straightforward. 2, assume the bottom note is the tonic in a major key. Okay, so what we're going to do is we're going to pretend that this F right here, this F and this B flat, that F is going to be the tonic in a major key. So let me count up. I'm going to go 1, 2, 3, 4. Now this is where you have to know your key signatures. And you've got to have, if you need a cheat sheet on the side, use it. So you ask yourself, is that B flat diatonic to the key of F? So it just happens to be diatonic to the key of F. It's the 4th note in the F major scale. So what kind of 4th is that going to be? It's going to be a perfect 4th. So that's how we figure these things out. So here with the A to the C sharp, I ask myself, I'm pretending I'm in A, key of S, the bottom note. Is that C sharp diatonic to A? You have to know these answers. Now I've looked here at A flat. Is E natural diatonic to A flat? No. So it's going to be an altered interval, a chromatically altered interval, and it's not going to be diatonic. Same thing is true for D. Doesn't have an A flat. It's not diatonic to the key of D. So that is an altered interval. So you really need to know your key signatures. And I have a chart for you for reference. It's also a separate PDF in Canvas for you to use. And it's this one. All the major scales with all of the ordinal numbers. So if I'm looking at F on this chart right here, I look up and I go, there's a B flat, because remember that key signature accounts for all the Bs that are going to be played unless there's another alteration. So yeah, that's diatonic to it. But if I had, for instance, the D, let's find D major, it's down here, in D major, and I had a B flat, that's not diatonic. So it's got some altered name. It's a half step lower. It's a minor sixth, not a major sixth. That's how this system works. So you assume the bottom note is a tonic in the major key. You check it against your key signatures. And then here's the third step. Assign qualities to the intervals. So if the upper note is diatonic to the lower note, like we have in the left example in F and B flat, the interval must be perfect or major, and it's labeled either P or M. How do you know which to do? All unisons, fourths, fifths, and octaves are perfect. Everything else is major. So that is a perfect fourth. And then you just label it with a P in front of the 4. Here, you've got A with a C sharp. C sharp happens to be diatonic to the key of A. Therefore, that third is a major third. With A flat, look at this. E natural is a half step higher than the E that occurs diatonically. The E that normally occurs in A flat is E flat. So this is up a half step. It's an augmented fifth. It's totally cool how this works. And then the last one, the D with the A flat that's above it. A flat is not diatonic to the key of D. It's altered. Is it raised or lowered? Flats lower things half step. It's diminished fifth. It's that simple. That's how you have your answer. So then the intervals, we would write them as P4, large M3, or +5 and 0, 5. And that gives us our designations for those. This is crucial. And then we have something with these called the consonant and dissonant continuum. Now we talked about in live lecture, consonants and dissonants. Here's one of the first applications of that. The most consonant intervals are on the left side of this continuum. And we say continuum only because this goes off into infinity, really. You could get almost forever, you could figure out tiny differences between things. And the size of intervals could grow out of human hearing and anything reasonable, but it's mathematically possible. So we have the perfect unison, that's the most consonant, followed by the perfect octave, perfect fifth, and then major third, minor third, major sixth, minor sixth, perfect fourth. You'd think that was a perfect interval would be the most consonant. In 18th century counterpoint that we're going to learn, it's considered dissonant. And it's because of its context. I'll demonstrate that in class. And then we have an augmented fourth, sometimes known as a tritone. We have the major second, which is getting really dissonant now, minor seventh, which is pretty dissonant, the major seventh, which is very dissonant, and then the most dissonant chromatic interval in our vocabulary and in our palette is the minor second. So play those. It's kind of fun because you get... with that very dissonant one at the end. We're going to use this as composers and when we analyze music. So we have this further classification. The perfect consonants are perfect unison, perfect octave, and perfect fifth. The imperfect consonances are the major and minor thirds and sixths. Then everything else, we're going to call a dissonance. We're going to call it that way because that was the convention from the 18th century. And you'll see why immediately when we start composing, why every one of those is dissonant. So we use them in composition, and composition is the controlling of melodic and harmonic consonants and dissonance over time. It's the axes we talked about. So we'll refer to the continuum as we compose and analyze music, and we'll use the classification system below. So notice that the Perfect fourth is problematic, and like I said, it depends on its context. So all our composing and analysis will use the diatonic and chromatic interval language. And then we'll move from intervals to triads next, melodies and chords and counterpoint. So your next in-class assignment is to bring in a melody, 3 melodies that are 8 bars long. So I'll give you more information about that. And then you will have a PDF you'll want to check out and fill out the answers to that about intervals, chromatic intervals, and bring that to class. So have a great time between now and the next class, and be safe, and we'll see you in class.